and doctors. There we go. And sessions with adopting on the right axis. So here we go. This is the basic behavior, right? So potential adopters are following as adopters are increasing. They meet in the middle, no surprise, and that's the same point where the number of people adopting peaks. That's the point where they meet. So there's the peak of that. Everyone familiar with that basic idea and structure? Question?
Your graph looks quite different.
Different, yeah.
My graph looks different than what?
Right axis.
In what way?
Right axis.
Oh, so this, I made this do this, so there's a number of ways I could make this do this scale this way. I could say multi-scale, or I could say I clicked on this and I put it on the right axis, so otherwise it'll look small. I don't do that, but you can keep it small. It's just, it's not, you'll notice it's not the same units. This is customers and this is customers per year, so I really want it on a different axis if I can. And the way you do that, if we open the panel for the graph, there's just this little checkbox, right? We select adopting, and I check this little checkbox that says right axis. So I selected adopting here, and then I said I want this on the right axis. That's how I did that.
And to make it...
Make it what? Fine. You ask any questions, it's fine.
I don't have the normal distribution, or whatever you call it.
Bell curve?
Bell curve, yeah. It's not showing up.
I'll take care of it.
Okay, thank you. Okay, so, do most people have this up on their computer now? Are we all set to go forward from here? Okay, so a couple of things that are interesting that you may not know. And I can show you these things very quickly, just because it affects sensitivity. And we're going to do a quick sensitivity test. So I'm going to create another page, and that other page is going to just have adoption from advertising. So I'm going to put the two adoptions on here. Adoption from advertising and adoption from word of mouth, okay? So these are on the same scale, and they should be. The blue is adoption from advertising. So notice at the beginning it's high, and adoption from word of mouth is necessarily 0. We have no adopters. But over time, what happens? Anyone? So when we start here, the thing that's making everything work is the advertising, but as we go on, what happens? The what? Right, the effect is much lower, right? Actually, it's getting dwarfed by word of mouth. So once we start the ball rolling, everything takes off. And if you were in the last session when they did the infection model, once we had somebody who was sick, it just took off. So this is to pull people in, or push, whichever way you want to think about it. It's called the push-pull system. In any case, right here is the point where they're equal, and at some point here it's going to drop off. And how much I spend for advertising is going to determine how quickly this happens, right? So we could run a scenario where we could look at different advertising levels and see how that affects the timing of this, because it'll change the timing. Everybody with me? So we're just going to do that, the sensitivity. So if I want to run a sensitivity, and I'm going to run my sensitivity, and I want to look at some variable. I want to know the behavior of some variable across these different values. Which variable do I care the most about? Effectiveness of advertising? No, I'm not talking about which one I want to change. I mean, which one do I want to look at to see what's happening? Does anyone know? What is it? Adopters. Great, thank you. So we want to look at probably adopters because that's what we're most interested in, the timing of the adoption of our product. If we are looking at an infection model, we may be more interested in infecting and how fast that's growing and where and what timing, right? But in this case, we're selling a product, we're probably most interested in adopters and how that goes. So we're going to create a graph. Here we go. I'm creating another graph. So I'm on this graph. If you haven't put a graph down, you can just select the graph tool and drop a graph. But if you have a graph, you can hit the plus sign up here, and it will create a new graph. So I created a new graph. It's a new page on the existing graph. I can drop another one also. I'm just conserving space. And there's a lot of junk on here, isn't there? Good grief, why is this so complicated? Look at that. Well, it's not as hard as it looks. It just looks like a lot of things. Don't have future shock, please. You'll be able to choose what you need. Here we have the type of graph we want at the very top. We want line, area, scatter, bar, pie, bubble, right? We're just going to do a line chart. If that's the default, we don't have to worry about it. The next thing is the thing we care about, this thing called comparative. It's going to let us see the results against each other from the different runs. So that we want to check. And I'm not going to talk about stash data. Okay? That's all I need to check on here. I don't need to do anything else except set the variable that I want. And we set the variable as adopters, so we're just going to hit plus and choose adopters. The plus down here, not the plus up there. Okay? Everybody with me so far?
Yes.
So now I have a graph. It's a comparative graph that has adopters, and that's my base case, but I'm going to clear all my data. I clear all my data by hitting this U-turn down here at the bottom. Is one way to do it. I can also do it from the menu, but it's just easier to hit this little U-turn down here in the bottom right. This clears all my data because I don't want anything in that comparative graph when I start.
Clear all data also clears initial conditions or only the ones?
What do you mean by initial conditions? It doesn't change anything. If I didn't install live, which I'm not talking about right now, then it does reset all those parameters. Okay? But I'm not install live. Okay? So far so good? Now we'll do sensitivity. So again in the panel at the bottom, nothing is selected. So I have nothing selected. I don't have the graph selected. I don't have any entity selected. I get, by default, the model settings. So you should see the model settings up here if you have nothing selected. If I have something selected, the panel shows me what's there for that thing that's selected. In the model settings, I have a number of tabs along the bottom. Don't be scared. We only care about this one right here, which is like to do model analysis type stuff, this magnifying glass. This one, by the way, lets you run by sectors or modules. This is styles. This sets posters, etc., graph styles, table styles. But all we care about is this one, okay? Model analysis, the third tab over. Oh my God, what is all this stuff? Wow. Okay. Let's not worry about what this is. So you'll notice, so we went on the tabs on the bottom, and then there are tabs at the top. We're, by default, in sensitivity. We don't care about the other two tabs. This afternoon, we're going to talk about the other two tabs. But for now, we're just talking about sensitivity, and unless you're doing optimization, you don't care about those two tabs either. You just need to worry about sensitivity, okay? So sensitivity is broken into a bunch of places. We can do a lot of stuff I'm not going to talk about right now, because we need to do other stuff. But what we will do is we need to set what we want to do here. And we have lots of options. The top option says, all combinations of all the parameters mixed together any way that we want. Well, we're actually going to just change one parameter, so that's a good choice for us. The next two choices allow you to do a random sampling from all those combinations, and you set the maximum number of runs that you want. Okay, and I'll stick to just talking about those two. But I'm going to select all combinations, And I'm gonna select all combinations because I'm only changing one parameter. There's no reason for it to random sample, it'll run all the combinations for me. We're just gonna check, we're just gonna do 3 runs. It's like, we don't need it to random sample. But if I have, 5 parameters that I'm pulling from distributions and there are an infinite number of combinations of those, I wanna do one of the other ones. Okay? Everybody with me? Okay, so our parameter that we want to change is the advertising budget. We're going to add that by hitting the plus, advertising budget. So the advertising budget, we don't actually know what the base value is, do we? 10 million dollars per year. So 10 is the base value. Let's go, I'll go back to sensitivity. And I'm just gonna choose incremental. I'm just gonna vary it from 5 to 15. Okay, simple effect. What effect does this have? So incremental's the default. I want 3, not 5 runs, so I'll change that to 3. I can just type it in also. I'm going to start at 5, and I'm going to end at 15. And it's going to evenly divide those. So my base run will be in the middle, which is 10, right? So it'll do 5, it'll do 10, and it'll do 15, because I asked for it to do 3. Now if I want to do 50% less and twice on the other side, which would be 20, I'd have to use a different, I'd have to enter those numbers, right? Because the incremental just does even steps, always does even steps. There's another thing called ad hoc that lets me enter in any numbers I want, but incremental, I just usually use incremental. It's close enough. Once I've set this up, you'll notice, maybe you can't see it over there, but down in the corner, there's something called S-run, which is for sensitivity run. The play button still does a normal run, but S-run does a sensitivity run. I can also just hit run up in here if I wanted to. So either place I can run it. I can do a sensitivity run. So I can do it from here, or I can do it from there. So, I don't know if all of you can see that. You need to stand up to see it. Questions? I see questions.
I'm sorry, I don't actually have that button.
Have you chosen all combinations and put the variable
You
in?
need to say bottom right corner. The moment you hit the tick, then the S enters.
A little green arrow at the bottom right.
That is true. It needs to be, needs to have a variable. So I'm going to deselect this, which also does the same thing as hitting the little tick at the bottom. And you can run S-run it. We very easily and very quickly done a sensitivity analysis on 3 values. Now, remember the middle one was our base case. That's our 10 million, this is our 5 million. Oh my God, I don't know. Do you guys know what those things are? I forgot what they are. Luckily, there's a button up here, right here. It says show sensi parameters. And it tells me that run, well, it's a little narrow. Silly. Is there a way for me to change the width of this? The number of names getting cut off. I thought I could change it.
Double click.
Okay. Well, anyway, they're in order from run 1 to 3. We know that. So run 1 is 5, run 2 is 10, and run 3 is 15. And you know, before you go any further, it's a really good idea to rename these runs. So I just click on it, and this comes up, and I can rename it. And this is at 5, I don't know what you want to call it. This is my base case at 10, and this is at 15. Okay.
What did you click on?
So I just clicked right on the legend here. There are other ways to bring it up, but if I'm trying to rename something, it brings it up, it's selected already, and I can just rename it. Those names will all get lost when I restore data, until it runs, but.
This is a graph that you don't generate by clicking on graph. You go.
Yes, I do. I can generate by clicking on the graph, or I can add a page to an existing graph, either way. Those are two ways to create a graph.
So, yeah, because but if you go direct to model settings, model analysis tools, you have been referencing to an already existing graph.
No, that does not even look at the graphs. If you go back to here, there's nothing in this sensitivity dialog that talks about graphs. If I did not set up that graph, I can't look at the data. But I can set it up afterwards, by the way. It knows all the data. It'll just put it in there after I set it up. So if I forget to create the graph, I can just do it after the run. And bing, it's all there. So the other thing to notice is in this bottom corner, the same thing that let me rename stuff is the database manager. And the data manager, is this little database symbol here, okay? And it's also in the menu. But the difference is, if I click on a label, it knows that I want to change the name, and the name is already selected. Whereas if I bring up the data manager, it's not. Okay, so if I'm changing a label, I just click on the label. Now, what can we observe about this? Remember, we just did the sensitivity analysis, and we're increasing the amount that we're spending on advertising, and we can see that that's making adopters come in earlier, right? The more we spend, the earlier they come in, and the difference between 5 and 10 is bigger than the difference between 10 and 15 by quite a lot, so we can start to try to make trade-offs. Right? This is almost twice what that is, right? Maybe it's a little more than twice. The impact. Of course, it was twice the money versus 50% more than money. So be careful. Okay, everyone clear on how to set up a simple sensitivity? So that's a simple one. Do you want to know how to do a more complicated one? So we'll briefly look at a more complicated one. Same situation. I'm going to clear my data this time. Again, just clear everything so that everything that shows up will be from this new sensitivity one. So if I go to sensitivity again, let's change, instead of advertising budget, let's remove that. And let's look at contact rate. Say we don't really know what the contact rate might be, and I'm just gonna add them first, and the adoption fraction, okay? So say these are very uncertain. I don't know what my adoption fraction is, I don't know what my contact rate is. I'm just gonna run over a range of values. I'm gonna pull them from a distribution. So contact rate, the base value is 100, and the adoption fraction is 0.015. I'm not gonna remember that, but we can come back to that.
I apologize, I forget how to get to the sensitivity thing.
So don't select anything, and then click on the panel. It's the third tab over.
No, I can't get the panel.
Oh, if it closes, there's a little arrow, and you can open it again. Or you can also double click on something that opens it. Double click on the diagram, that also opens it. Okay, so for the contact rate, it's at 100, and let's just say, you know, this is just crazy, but let's just say it's normal distribution, and let's pick 100 values from that. I don't care what the seed is, so the mean is 100, and let's say the standard deviation is 10, that's plenty. Okay? That's all I need to set. I don't really care what the seed is. So, contact rate, we're going to say it's normal with a mean of 100 and a standard deviation of 10. That means 3 standard deviations is 30 away, right? So that's a reasonable range. And the adoption fraction was 0.015, right? So we'll just leave that as the mean. So I asked for 100 samples, by the way. I'm going to ask for 100 of the other one. How many total runs would that be? If I did all combinations. Yeah, which isn't going to take long, but I don't want to do 10,000. So we'll address that in a minute. But let's first change the adoption fraction. If everybody's with me?
Yeah.
So the adoption fraction we will make also, just to be lazy, a normal distribution. We want 100 of those. And the mean is 0.015 or not.
0.
okay?
What is a seed?
Doesn't matter. It's the seed for the random number generator, and I don't care what it is.
0, comma.
So you set the seed so you can replicate this later. It doesn't matter what value you put in there.
So
Okay.
if your computer is set up
And the
with
standard
American,
deviation,
use a dot. If it's set up as European, use a comma.
yeah, if it's European or Brazilian, use a comma. If it's if your computer is set up for the US, you use a period. So this is actually their computer, so if I were doing it, it would be a dot. or
Right,
use a
right,
comma.
very
It's
confusing.
so strange. I don't know what that means. Okay,
Right.
and let's set the standard deviation to 0.002. Okay? Otherwise, I need to set the minimum to 0. This way, it won't ever go below 0.
What, I'm sorry, the standard deviation is?
0.002. Okay?
Yes.
We may get some really crazy results. And I am going to do a limited number of runs. I'm going to choose Latin hypercube sampling because I see no reason not to. It's going to give me the biggest representation of my search space, so I'm going to use that.
You want to just give us a hint of what that means?
I just did. It's going to give you the best representation of your search space. Beyond that,
Beyond that,
it's going to be very well spread out across your search space. And I'm going to say that I only want 100 runs. I'm not going to do 10,000. Okay?
And that's different from the number of runs that we put in for the sensitivity parameters?
Correct. For the sensitivity parameters, we say how many values do you want it to draw. So it's going to draw 100 values from each one of those, and then the Latin hypercube is going to. These are the ones we're going to use.
50, 50, 50, I understand.
It's kind of like this kind of thing. Okay? And then we can run it. And when we run it, this will be interesting. We get this.
Oh, no, we didn't.
I'm going to make it a lot smaller.
No, I did something.
Okay? Now, what specific parameters did you choose for all those 100 runs, and which ones do we care about? Here, we can just click that S button again, and here they all are.
I'm not good at your trackpad.
Okay? And I can click include output variables here, and it will tell me what a doctor's was for each of those values at the end of the run. So, you know, this isn't really, you'll notice this isn't very useful because most of them are pretty much near done, right? They pretty much reached the top, so that doesn't help me much. So what can I do to understand more about what this bunch of curves means? Well, one thing I can do is I can draw differently. So I can say plot confidence values instead. Okay?
Can I ask a question?
Of course you are.
So not regarding the software, it's what exactly does all of this mean? What are we trying to do? Sorry.
That is a great question. So let me finish this and it'll be clear.
Okay.
As I said, that was a bunch of gobbledygook. You can kind of see the pattern. What you do see is the behavior mode doesn't change for the changing those parameters. Behavior mode's the same. What's changing is the timing.
Yeah.
So that's an important thing to know because the behavior mode could change. So one of the things you could be testing is, I have an uncertain parameter. I have a couple of uncertain parameters. Does changing them change the behavior of the model?
Okay.
And in fact, no, it's not changing the behavior of the model.
So it doesn't really matter. what
So it doesn't really matter, but the timing may matter. And so it's important to then we can do the next step.
Okay.
So on the next step, I went back to my graph, which was a comparative, and instead of just plotting the lines, I'm asking it to plot confidence intervals. They're not real statistical confidence intervals, but bounds, confidence bounds. And we can include the mean or we can include the median. And by default, they do accept the 50th percentile, 75th percentile, 95th, and 100th. And we can turn off the mean and instead put the median in by putting 0 in here. That would be the 0th percentile, right? Okay, so just by default, So you'll notice the mean, which is the orange line, isn't in the center. So it's not, you don't generally use that with percentiles, but it's useful to know it might be skewed, right? So that is telling us it's a little skewed because the mean is not dead center. So that, to me, is useful information. But what this is showing us is that for 50% of our values, it's in this range, and all the way out to, I forgot what the top is, 50, 75, I don't care about 100, 95, good. So 95% of the runs were between these curves. So you could say, you might actually have to do a statistical test, but ignoring the statistical test for a minute, you could say 95% of them were 95% confident. I'm really playing with words here. That it's between here. I'm putting this all in quotes because this isn't really sound. You have to do some statistical tests. But anyway, it allows you to see that this is the range for 95% of our runs anyway. And then to find out for the real mean, the real population mean, you have to do a statistical test. But you can show, so I'm uncertain about those parameters, but I might be happy to report that out of all the simulations I did across the range of parameters where I think the parameter could be, 50% were in this range, right? That is useful information.
Would Stella run statistical?
Test for you? No. Sorry. But it's very easy. Very, very easy. If I just go into here, and I click the S button, I can export this to the clipboard. I can paste it into Excel and run the data analysis. It's like that. That's the answer. The answer, right? Bing, or whatever other program you want to use. But Excel does it very quickly.
Okay.
You don't actually have to use a statistical package for something like that. Okay? Yes?
The sensitivity run is using the same start and stop interval.
Yes.
That we.
Yes, it's everything that we set up for the.
Also the DT.
Everything is the same.
Okay, regarding the DT, you are choosing 0.0625.
Yes, and what is that fractionally? Do you know? 1/32. No, it's 1/16, isn't it? 1/16. It's 1/16, yeah, because 125 is 1/8. It's half of that.
Is there a rule of thumb to choose the right DT?
Let me look. It's not on that thumb. Might be on that one. So, DT, yeah, so there's we have a blog article on that. We also have something in our documentation about that. So basically, we default to a DT of 0.25. And that works great across a broad range of problems. But your DT has to be less than half of your smallest time delays, right? So you may not even know what that is. They're usually parameters, but you may not even know what that is. If you do know what it is, you just cut it in half or cut it in a quarter. If you don't know what it is, start with 0.25, it's fine. Have it. Has anything changed? Have it again. Has anything changed? Right? Until you get what you want. And you might also have to use, we're also using Eulers on this, right? You may need to use one cutter for certain problems, which Bob touched on last time, when you might want to do that.
Can you show me the parameter that you set up for contact rate? Because
Oh, sure. I just used a normal distribution again to keep it easy.
Yeah, I had the normal, I lost the.
And then so the initial value that I have in here, I use as the mean. Oh, for contact rate was 100. I set the mean to 100, and I set the standard deviation to 10, so that 3 standard deviations would be 30 away in either direction. Yes.
So just based on my question, just based on the graph of the confidential, of the housing, the confidence. So if I run this sensitivity test and show this graph to my clients, so what kind of value can my client get from this graph?
So if I know, So something's uncertain, but I know how much that's uncertain, what the range of uncertainty is. This is telling me how that translates into range of uncertainty in the output. So if I have a certain range of uncertainty in my parameter, this is telling me the range of uncertainty in my output. So say my parameter varies as I said, right? I don't actually know what it is, but this is, so the 100% line is like, that's the total uncertainty that I get out of it. But you can decide, you know, I don't care about 100%. It's close enough. You pick the range that you care about the most. And again, this is not a statistical test. So you might want to take the data out of here and do a 95% confidence interval for real, a real one.
Yeah.
Right? Find the p-value.
Yeah. So may I say, so sometimes my client will only be able to provide me with two ranges about these two parameters. So, and then I run this test and show my client, okay, so given the range of parameters you gave me, I can say for this much of confidence, your outcome would be like this.
Correct.
Thank you.
What will be in this range?
Yeah.
Are there other questions? No? Okay. Great. So that's like just tips and tricks. Now let's get into managing complexity. Yes.
Question. So we just choose the normal distribution, but if we do
No, there are many distributions. You can pick any one you want. You can have it instead of IDAC values, you use incremental, you use a beta distribution, log normal, whatever. There's a whole ton of them right there. I pick normal because it's easy. 2 parameters, everyone understands them. Everyone knows what they should be, right? 3 standard deviations, we want to stay within, right?
Okay.
So
But if I choose another method, maybe the graph will be different.
it will be different.
Yes.
I guarantee you. Okay? Any other questions about this? Good question. Yes?
So we're doing a sensitivity analysis and we're varying 2 parameters at the same time?
Correct.
So what is that really telling us here?
So
This is the range of behavior of this graph.
So I have, typically, if I have uncertain parameters, I usually don't just have one. So I have 2 uncertain parameters that I've described, the uncertainty around those parameters. And this is telling me the range of behavior that I get from both of those changing across. Because I don't know, I'm not going to just pick this one and this one, it's at preset values. And I use Latin hypercube to make sure I've really sampled that full space. That will guarantee it, as opposed to a pure random sample, which is okay sometimes. But if I'm trying to explore the space of the uncertainty in those 2 parameters, I'm going to use Latin hypercube.
The number of runs.
Really? So how much time do you want to spend waiting for the answer? It will change the answer, but we'll change it dramatically. I think 100 runs is more than enough for this one, right? 100 with 2 parameters, 100 runs is going to give you a pretty good idea of what's going on in that space. Of all the combination of those 2, you don't need 10,000. You get 3 parameters, that might be more. 200, to some extent, trial and error. Here's all part of that rule. I can look at here all day, but it's not that. Okay? So let's move on to managing complexity, which is the main purpose. Well, we wanted to go over this too. And actually, I forgot we could easily set up the multiple variables. You guys might want to use that. You might need that. So back to where I've never been. PowerPoint. My first PowerPoint. So we're going to look at 2 ways of managing complexity. The first one is using modules. The second, which you don't know what they are, everyone doesn't know what those are, that's fine. First page, what is a module? And the second one is using arrays. And you may not know what arrays are either, but most people I think do know. It's something you ask for, but you rarely get. Okay? So, sorry, I can't count myself. So, we'll learn what an array is too, but I won't do it with slides. I do have slides to do it, but not on this computer. Anyway, so all modules is something that holds a bunch of structure for me. encapsulates it into a small thing that's on my diagram, and then I can talk between things. It allows me to arrange my model in a hierarchical fashion. So I can do things like designing my model from the top down or from the bottom up. And though I'm not going to show you because we don't really have the time today, one of the ways to build your model is to build your dynamic hypothesis at the very top with modules, and then fill out those modules and make it work. So, Ricardo, por favor.
I did not get this part here. A module is like
We're going to have examples.
we're gonna have it.
Okay? So we can put structures related in one place.
When you say bottom up or top down,
Yeah.
is that, if I want to translate it to the real word, would that be if the decision is made?
Am I not talking really well? Oh my God. So what I just described was kind of working from the top down, from the highest level to the most abstract level to the most detailed level. Bottom up is from the most detailed level up to the most abstract level. So I said you might start, like typically I will start. I'll build a dynamic hypothesis and I'll put modules together and I'll show it. And by the way, there's my CLD of my dynamic hypothesis.
Okay.
And then I'll go and I'll build details. But sometimes I know something way down at the bottom and I know how to build that and test that, and I'll do that first. So that's working from the bottom up.
Okay.
So you often end up working whichever way, but those are software engineering terms.
Okay.
So,
Okay, so from a software engineering term, so you might have your design phase as
Yes.
a module, and your requirements phase as a module, and your testing phase as a module.
exactly, you would.
Okay.
You definitely want to do that. You want to, one of the things that modules let you do is spread these tasks out and handle them in small pieces.
I tried to do it in iThink, and I was not successful,
Using modules?
just because of my limited knowledge.
Okay. So, as I said, it lets us build our models into some hierarchical structure. That's okay. Let me keep going. You can ask your question when we're done.
Okay.
Stop interrupting my presentation, Ricardo. This is my presentation or yours. These Brazilians, you can't take them anywhere. Eu sou quase brasileiro. Can't take me anywhere either. Look, we build these things out hierarchically. So we start at the very top level, and then we have a group of modules under there, and then modules can have modules inside them, and so on, all the way down. They have inputs and outputs, so they're like functions, both mathematical functions and computer program functions, which are named that after mathematical functions, even though they aren't exactly the same. Okay? And it has nothing to do with how things simulate. This is an organizational thing that we're giving you. It doesn't change. What it does let you do, there is something about organization and simulation. You can run just one module by itself, or one module with another module to test. Okay, so let's look at some modules, Ricardo. They look like this. Okay, this is the shape. You can have a name, housing supply, housing demand, and I have a connection between them. So in here, I have some structure that will look inside that. And this is actually what that real module looks like. Okay? It's just structure. And then this structure is connected to there, and I'll explain that a little more, but it's this variable that I'm going to send over there. And then in here, I also have some structure. And on this side, we have many things from other places, but let me pick, it's getting a little fuzzy. Can't really see it that clearly. But housing demand, demand for houses, that came from here. And that's that connection. Okay? So it gets calculated here, and it's actually connected through this over to here. Okay? Now that actually icon looks different, but at the smaller scale it's hard to tell. So I will talk about those icons right here, and there's a very clear indication of the real connection behind the scenes, but I define what my inputs to my module are and what my outputs are, and then I can connect things between them, and we'll do that. So don't panic, we'll do it. And I thought I had a slide that showed all the different parts, and maybe I don't. So anyway, it maps the projects there hierarchically. It allows us to functionally decompose our program, so we can define our models. So we can break our models into well-defined pieces that we can then build independently. We can test them independently and in combination, which is a very good thing. It allows us to present our model at different levels so people can understand it better instead of seeing this, they can see, oh, at a high level, this is what's going on. At a low level, this is what's going on. And you can also break things up so that individuals can work on individual modules. You can do source control on individual modules. You can do regression testing on individual modules. And it also allows you to reuse common structure, which you won't be able to show today. We don't have time. I already talked about version control, and I don't want to do. Good. Phew. Okay, so this is a module symbol. This is a module output. It has a circle in it that says O for output. Okay? So that's something that goes out of here and into there, or anywhere else you connect it to. We have a module input that's a placeholder, which is a heavy line. It says you want to do something with this, and that's in here at that point. It's just a placeholder. And so these are the symbols you need to know. And if it's assigned, you get a heavy dotted line. It's like a ghost. We call it a cross-level ghost. So it's it's gray, but it's really like a dashed line.
So you would
And-
first, in your housing supply, create this thing to just say, all right, I know I'm gonna link to this.
Correct.
And then once you say, this is what I'm linking to, it changes its name.
Exactly. And you can build this whole thing with default values in this variable, and you can test it any way you like.
Because those links, I just could not get that.
And then we'll do that in just a few minutes. And once it gets assigned, you'll notice the name changes to match this. It has the name of the module, a dot, and then the name of the variable. So we know which module it came from and what the name was over there, but the name here doesn't have to match. We will use the ghost tool to actually create these connections instead of doing it manually. And when you do that, it picks the local name is the same name as this, so it was the demand for houses in that case. Okay? I think that's all I want to show you in slides. Yeah, we're not going to go through that.
Kareem, do they nest?
Do what nest?
Modules.
Yes. Yes.
And unlimited
Yes, go back to
variables.
this picture here.
Ah, thank you.
Unlimited variables.
Unlimited. Oh, it's only limited by your imagination. Okay? Everybody okay about what they are? Ready to do it?
Yes.
Okay, so what we're going to do is we're going to take, we're going to create a new model, so we're going to close this, get rid of this thing. You can just do it new. I tend to just close things I don't want to save. Just close the whole thing, make sure I don't save it. But anyway, so I want a new model. You can just select new model and you don't have to do what I just did. And we will go up to make it a little bigger. And we will call this, so the module is right here. See where I'm pointing? It's the fifth thing over. It's called module. And if I click on that and I drop it, voila, a module. And I want to name this module. I'm going to put my bass diffusion model in here. So we'll call it, I don't actually want to call it that, but I guess we will. I'm going to make up a word, adaptation. We can also, let's just do this. We can just call it the market, if you like, for now. I think that's easier. Why isn't there a word, adaptation? Who gets to decide what's a word, what's not a word?
OEE, Old Oxford English.
Not in the United States.
They keep ending up on Jeopardy.
Oh, really?
Yeah, the new words added to the OEE.
Okay, so I am in modeling mode. I don't know, I changed that. And I'm going to open my panel here, as it was closed. And I'm going to select this module. So when I select this module, again, I am in
Import.
There's no choice down there, but I'm in the X squared mode up here. Right? I don't have the gold there. If I just have the gold there, I only get documentation and style maybe.
You can get the globe if you click on the X.
Yes, I don't want to be there.
Okay,
I don't want to be there, I want to be here.
okay.
Okay? For this whole thing. And you know, I use that, but we don't need it for right now. So, we have the module panel, and we have a lot of options here, but the only thing we care about right now, so notice, you should notice that you can put an image in there, which is great. If you wanted to show this to people, instead of putting the name in, you can put an image in there that represents what's in the module, so when you're presenting, people can see that. That's very good.
Very good.
You can password protect it if you don't want anyone to see what's in there. When you share the model, it's confidential for whatever reason. Could be national security. You can also save it in a separate file, which we're not going to do. The only thing we care about in this right now is the little button that says import. And that import button allows me to pull in another model into that module. And I already have another model. What other model do I have? The Bass Diffusion model. So I am going to import the Bass Diffusion model into this. And I want the top of the USB. There we go. Okay, so I just pressed that import button up on the top right. I navigated to the model, and I said import. And is anyone going to be surprised that when I double click on this module now? So we have modules. There have to be ways to get into modules, ways to leave modules. We also have a new feature where you can just look at what's in there without entering it, but we're going to just go look at it, okay? So we're going to double click it, that takes us in there, and here's our module. This is our Bass Diffusion model. Does everyone see it? This is a different view. I'm not looking at the top anymore.
This is your
I'm looking inside this module. And how do I know I'm looking inside this module? I know I'm looking inside this module because at the top,
I see.
the name of the module has appeared next to the file name in square brackets, and if I were in multiple modules, it will tell me that. And up here, I have two new icons. BassDiffusion.stmx. It's okay, not a problem. And so I have these two icons now. They're how I navigate back. So the up arrow goes up one level. The home button goes all the way to the top. In this case, I'm only one level down, so they do the same thing. But if I have multiple levels, one goes up one level, the other one goes all the way up, always.
Where is the button?
Right here. So we used to have them over here, but we don't have anything over here anymore, so they're up here.
And if you want module, you can have different marks.
Yeah, I can add another module, I can add another module, I can go down many, many levels. I could show you examples if I could plug in my computer, but I can't. Possibly don't have a lot of time.
So you clicked on the module, you clicked on the import button, you selected the file.
I selected the file, and then I double clicked on the module, and here I am. So I can run this independently,
Okay.
right? We're not going to do that right now. We'll do that in a minute. So let's go back up. So I just did that to show you it actually worked and it's there. And then I'm going to create something called sales or something. Doesn't matter what we call it.
And you got back to their account?
I click the up arrow. Yeah, so let me go back.
Oh, there it
I'm
is.
in here and it's right up here. Do you see
Yeah,
it?
got it.
Now we'll connect those together with a connector. I don't strictly have to do that, but I will to illustrate something else. At this point, it's not happy with me. Why? Yeah, there's nothing connected, right? I've just connected the modules, but I haven't actually set up any connection between them. And if I hover over it, it will tell me that I haven't used market inside sales anywhere, right? If I double click on sales and I go into it, there's nothing here.
Yes.
It's a blank slate. And I'm not gonna import anything, I'm gonna build something very quickly. We'll build just a small thing because we're running out of time. I was gonna build something bigger, but we have, at the top it says we're in sales and we can see we're in the module, right? Okay, so what do we want to put in here? We have units that are getting sold. So I'm going to call it something crazy. Actually, you know what? I'm not even going to do that. Let's just go right to the real thing. So what on here is what I'm selling. Where am I selling units? Adopting. So let's move adopting over to the other side, even though it's going to be funny to call it adopting on the other side. Okay? It's going to come from here anyway. How do I move it from here to there? You guys used the ghost tool last time, right? So we're going to use the ghost tool. So the ghost tool is...
We haven't used the ghost.
Oh, you haven't?
No.
You didn't use it in the last class? Oh, I'm so sorry. We'll use it right now. So the ghost tool allows you to move, to have a representation of the same variable elsewhere in the model, so you don't cross connections. So for example, here's how the ghost tool works. Click on the ghost, which is right next to the module. You click on the ghost, and you get this little guy going, okay, as he goes around. And then we click on something, say, I want to use adoption from advertising somewhere. Notice it highlights when I go over it. I click on it, and then when I come over it, then I move to where I want to put it, and I can put it here. And it gets this outline image that says it's a ghost. And it also is in italics that says it's a ghost. Okay? And then I can use that as an input to something else. So say I wanted to use it here, I didn't want to cross, so say I wanted it in there. If I drew it from here directly, I'd have to go through all this stuff. I don't want to do that. So we use it to avoid crossing connectors and make the thing more readable, the diagram more readable. That's the main use of it. We are not actually doing that right now. I just wanted to show how the ghost tool works in general. But you can also use the ghost tool to create a ghost across levels, across modules. And it'll create the connectors if you don't have them. But we already created it, just to make the point. So we are going to take adopting and we're going to ghost it over in the other thing. So watch what I do first. This is a little tricky because I have to go through a couple steps. So I'm going to take the ghost tool and I'm going to click on adopting. Okay? You can do that much if you want, but then go very slowly if you want to follow the rest of it. But I want to ghost it into something else. So I have to go up a level, and I want to ghost it inside sales. If I click right here, you see how it's showing me the converter? That will be the ghost at this level. I don't want it here. I want it inside sales. So I click inside sales, I double click, and now I can drop it here. And there it is. Bang. Now, and notice it's a thicker dotted line instead of a thinner one to tell us it's a cross-level ghost. And it has the module name in front of it. Okay? Now,
I lost the part of copying. It is cut and paste, copy and paste.
I use the ghost tool.
Ghost, click on one.
And then I go up and across. So the biggest problem that people run into using this is they accidentally click somewhere else on the way. And they don't end up inside the module where they want to go. And that's why I said let's go very slowly, especially if the name of the thing is inside the module, they end up double clicking on the name. And then they lose the ghost tool.
And the copy and paste function doesn't do the same thing?
No, copy and paste makes a copy of it. We don't want a copy of it. We want the real thing.
Okay.
This is the, okay? Can I have everyone's attention for a minute? This is a critical point that I was just asked about. This is not a copy of the variable. A copy of the variable is not going to give you the same values. This is the same variable. This is a reference to the exact same variable. Okay? So what can I do with that? So we can do things like calculate unit sales and the revenue we get, right? And that's all we're going to do for now. We're just going to do that much because we have to look at something else. So we can say, what are my unit sales? Unit sales. So to know unit sales, I need to know how many people are adopting, and I need to know unit sales per adopter, right? How many, they might buy 5 instead of 1. Everybody with me? So the average, we'll just make it 1 for now, but we can make it anything we want. And I'm gonna connect those together. And what is the relationship inside unit sales? What would that formula be?
Unit sales per adopter times market adopting.
Perfect. So I just click on here, I click on the times, and I click on here, and there's the formula. I'm all set. I'm not gonna deal with units because I really wanna show you something else. Okay? And then we can figure out our revenue. So unit sales is gonna be per time, by the way, and so is revenue. So revenue, and then I'm going to have, how am I gonna get revenue from unit sales? Price, average price per unit, right? And let's say that's 100. And we're just gonna multiply those together, right?
Yep.
So unit sales times average price. Very simple module. And I can run this, and this runs everything from here. And here's something interesting. Did anyone expect it to do this? There's our revenue.
What is the average price?
I used 100. It doesn't matter though.
Okay, yeah.
We get the same
100.
behavior. Did anyone expect it to do
Right,
that?
right.
We're out of business. Boy, that was fun. What are we gonna do next? So there's a more complicated model, which I'm not gonna go over, but just to show you. This is how we stay in business. We come out with new stuff. We obsolete the old stuff, so we get more sales.
Sorry, how can I run?
You have to come up with new stuff, new products, new things, or you're not gonna stay in business. Right? There's no way. Because once everyone's adopted it, you have no
So
market.
unit sales per adopter.
You could expand your
One.
potential market. That's possible.
We hit the
It's
check.
another option.
And now you
Go
can.
into new areas. And you can go into new areas that aren't geographic, right? You can go into new, like, say we sell into medicine, we could now sell
Right
into
click, sorry.
lawyers, I don't know. Pick
Just
something.
make less durable things.
But in general, what it does is it convinces people to make less durable things. That's true. That's exactly right. Planned obsolescence. Okay, so there are a lot of interesting things around this model, and we don't have time to go over those interesting things. Does anyone have questions about modules? I would really like to be able to show you some more stuff about it, some more examples,
About
but,
models here, I just, what I want.
and I can create a
What
graph.
you go now, you were on the converters and now you back on top of the model.
Correct.
I did not
Yeah.
get, where these converters, they were where?
Inside sales.
Okay.
So, they're in here, Ricardo.
Okay.
Can you show us the values that you put in each? We did that.
Sure, I just used 1 to start with for here,
Okay.
it's simple, and I used 100 for average price.
Okay.
But you can use anything, you'll
Yeah.
still get the same behavior. It's just, this peaks at 100, it peaks at 40 million. But it would be 100 times less. 1/100th of that if I used 1. Okay, other questions about this?
Question?
Yes.
Where does the ghost come from? Is it in the marketing sector?
Where does what come from?
The gas. Ghost.
Oh, the ghost, yes.
Okay.
Yes, the ghost came from here, so I ghosted, this, and you'll notice it has the O on there,
Yeah.
which means it's a module output,
Yeah.
and then I put that into the other one. Does that make sense? And by the way, I can, disconnect it here. I don't wanna go into this though, this is too much, okay? So the easiest thing is to just use, the ghost tool whenever you can. But if you preset a variable before you have everything set up, then you will wanna use the right click menus, let you do the same thing manually.
more complex models, do you have like a general rule of thumb for how many connections between modules there should be? Like in this one, we just have one.
So there would be just one, so this is a thicker connector also.
Right.
So any variables that move from here to there go through that one connector.
Sure, yeah, no, I get that. I more mean like.
So if I have multiple modules and I want to put them all together, yeah, you want to be careful that you can actually still read it and you can still work it. So I have an example. I don't think I have it on here. Maybe I do. Let me just check. That might help answer that question.
I more mean how many like inputs should be coming from one module to another versus breaking it up more into separate modules. Like in this one, we're only taking adopting.
So let's just look at
Wow.
this model. So this is urban dynamics, and this is the original model that's sector-based, and this is a direct translation of that. Okay? And it's, yeah, can anyone read that? Attractiveness for underemployed. Like, so it's very obscure at that point. And so as far as number of variables that go across, you know, that's kind of, I don't know if that's important to focus on too much, because you could have an array variable that also has a million values that come across, so. But this is important. So it turns out, if you look at this a different way, and you actually try to break it up hierarchically, and you try to think about what the feedback loops are, you can get this instead. And this is the same model. All I did was say, what are the major feedback loops in this, and let's bring them all to the top. And then break it down underneath there. So the top level shows us all the feedback loops in this model, the major feedback. And then at lower levels, oh, look, at the next level down, I have more modules, and then I have more modules, okay? So that is an important point. You may need to refactor, we call it in software engineering, how you're breaking up your structure. You need to change it. Okay? Great question. Other questions? Okay. So, one last thing that we're going to talk about, and we don't quite have the time, but we're going to do it anyway, because I think we can at least talk about it a little bit. Okay, so here's our fast diffusion model. And our fast diffusion model, as it stands, works really well for one company or one product. But let's say one company that's trying to sell this product. What if we want to know about other companies that may be in the market or maybe emerging in the market? We'd have to replicate this entire structure, right, for each company? I don't actually do a picture on the slides, but I won't bore you with it. We could do two, where we replicate the whole thing again, but then it becomes unmanageable. So if I want multiple companies, the other way we manage complexity is we use arrays. When the structure is identical for several parties, we make several versions of it by just arraying this, and we set the parameters differently for each one. Okay? So, how do we do that? Well, first of all, we need to decide what our dimension is. What are we arraying against? We're looking at a number of companies, and we need to sit down and we have to say, okay, how many companies are we talking about? Let's say we're talking about 5 companies. Okay? So I'm gonna, before I do anything, and if I'm building a model, I won't necessarily do it this way, because this is an existing structure. So an existing structure, I'm gonna think about what it is I want to array, what the dimensions are, and in this case, it's companies. It's which company I'm talking about. I'm gonna go into the array editor, which is under model, and I'm gonna say company. If I'm building a model, I do this, I get it here directly from the panel. And I'm gonna say there are gonna be 5 companies. And you know what? I don't want numbers for the companies. I want to give them labels, so I just select the label here. And then it gives me default names. And I'm just going to call them
Array
company
editor.
A,
Okay, thank you.
company C, company D, company E. Now, that's not important. I could still call them company 1 through 5, but companies usually have names, so I'm just giving them arbitrary names. You don't have to do that. You can keep them numbers. Does everyone see how to do that? Just type in the name. I said how many there were, and then I decided to make them labels, but that's optional. Okay? So now that I have that, I can go around my model and say what is related to the company and what isn't related to the company. Clearly, the number of adopters that the company wins is related to the company. So, and who gets adopts to each company. But the potential adopters, that's not company related. These are the people who may buy this product, the total population of people who may buy this product no matter what company. So I'm not going to rate that. I can assume that some things are the same for every company. So let's assume that the adoption fraction, the contact rate, and the effectiveness is the same for every company. We'll just change the budget. Okay? Just to keep things simple, but we can change all of those. And so then I can go around and see what do I need to make an array to make all these things work. So I'm going to have to go around here and make these things arrays, and I have to make that an array. Okay? So how do I make those an array? Let's start with adopters. I just click on here, and the very second thing, at least for stock, is array. So an array is just a bunch of stuff stacked on each other. So the picture is a converter that's stacked on top of each other. And to move it, and so I click on array, and array allows me to select the dimensions. So these are the ones that I've defined, and these are the ones that I'm using. These are the ones I've defined for the model, and these are the ones I'm using for this entity. So I'm only using one dimension in this entire model, so it's not hard. I'm going to move this over to there for every single one.
I'm not getting that. How do you get that?
Right here.
Yeah, I'm not getting that tab.
You're not getting that panel? Did you click on adopters?
Cream, did you want them to open a different file for doing this? Did you want them to follow along with you? Or?
Yeah, they're going to follow along.
Okay, so, okay.
I went back to the DAS diffusion model, right?
Make sure, make it say X squared. X squared means you're entering animations. Math means you just go to the diagram.
Yeah, so yeah, it has to be X squared at the top. So, do you have it now?
Yep.
Okay. Does anyone else have a problem finding that tab? Just right here. And this tab is very simple. Now there's a checkbox where I can check it to be arrayed, but if I add a dimension, it just does it for me, so I don't need you to think about that. If I want to turn it off, I need to think about that, but otherwise, it's a quick way to turn it off. But if I want to turn it on, I can just move it. And I can move it by selecting it and using the arrow, or you just double click it and it moves over to the other side. If I double click it again, it'll move again. I'll have a two-dimensional object. Let's not go there. Okay? And then I just want to do that for everything around this entire chain. So I click on the next variable, I click on the next variable, I click on the next variable, I click on the next variable. I want to make advertising budget change, and
Holy cow.
okay?
Yeah.
And a new or controls it, you need to create all arrays beforehand in the array editor before you can use them. You can't create an array for each one as you go along.
No, I can as I create it, right? So this model already existed. So I don't need to, right? This model already existed, so I didn't need to, I'm not building it as I go along. Now I'm saying I have this already, I want to array it. So that's how I would do it. If I were building a model from scratch, I would, as I put things in, I would be hitting on array. Each thing as I go.
You can do that.
Yeah. So this is a little different. That's what I tried to say. This process is a little different because I'm taking a model that already exists and I'm saying I want to array it. I'm not building from scratch. If I were building from scratch as I go, I would never directly, I wouldn't even have to directly go in the array editor because the array panel puts me there automatically if I try to array it. So, we do have a little problem here. We do have a little problem here, and that's my equation here. My equation here, my equation here is trying to figure out how many potential doctors I have to begin with, because I don't know how this has been initialized. And so I'm just subtracting a doctors, but I don't have one a doctor anymore. I have 5 of those now. You can see them stacked up there like cards. So the question is, what do I do about this? We have a bunch of array functions, and one of them, so if you look at this panel, on the built-ins, we can select things, and one of the lists is arrays. This can show me the array built-ins. So I can do these operations on arrays. I can take the mean, I can take the product of a couple arrays, I can sort them using rank, I can find the size of one, I can find the standard deviation, and what I care about here is the sum. I can take the sum. So my potential adopters are my whole population minus how many I've already adopted. So that's the sum of them. So I do need to add sum in front of adopters to make this work. Does everyone understand why? There isn't one adopter stock anymore, there are 5 of them. But because they're all in one group, it allows me to sum them just like that. I don't have to say adopters 1 plus adopters 2. Because what if I change the dimensions later? What if I want 10 instead of 5? Then I'd have to change this equation, but using sum, it just does it for me, no matter what happens. Okay? And that should work. The advertising budget for everybody's the same, so what do you expect to have happen?
When you were defining these array variables, did you keep the same parameters for the companies, or does each company have different parameters?
So, 2 things. First of all, the only one I allow to vary by company right now is advertising budget, just to keep things simple. And they're all exactly the same. So
But
what would you
can
expect
go
to
in-
happen?
You can go in and define specific for them.
Yes.
So it's gonna go down because the doctors.
So, let's draw a graph. I'm going to put a graph down. Now this is tricky. I want to put adopters into my graph. Okay? So I just dropped a graph. I'm going to hit plus, and I'm going to hit adopters, and I get this dialog. Whenever I click on an array, I will get this dialog. Okay? And this dialog lets me pick a specific element, or if I use star, it picks all of them. So I want all of them in there. I'm just going to leave it at star.
Sorry, how did you get to that?
I hit plus on the graph, and then I chose adopters. And then I press OK again, and notice it put, well, it's off the bottom, but it put all 5 of them in there. And if I scroll down, you can see all 5 automatically went in there. So if I run this with all the same parameters, we would expect them all to look the same, correct?
Yes.
So they are in fact all the same. That's kind of boring. So we can do a couple things. First of all, we can change the number of adopters they have initially when we start, or we can change the advertising budget. Let's change the advertising budget. So everyone's advertising budget to start with is $10 million per year. But how do we change it? There's just one field here.
Apply to all.
So if I'm in an array, I have this option of apply to all, where the equation gets set for every single thing, and there are also options I can do based on that, which we will use just briefly. Or I can say not apply to all, and I can individually set values. So let's start with that. So I can turn apply to all off, and I can say for each company how much they will get. I have to enter a number for each company. So I'm on A. How much should A spend?
8.
8? Okay, how much should B spend? 0 is not an option.
5.
5? Okay. How much should C spend? 3. How much should D spend? 6. And how about E?
One.
1.
Why are they
Okay,
all going to
so,
I lost a lot.
Why do they all go to
so they've all made their decisions about how much money they want to spend on advertising. Notice they all decided to spend less than what we were spending when we were by ourselves. So who do we think is going to get the most market share here? I'm not calculating market share, but who would get, you can see it from the graph anyway.
Hey.
Hey. Let's see if that works. So, most adopters indeed went to A. And let me scroll up a little bit so we know what colors are. So D got the second, and B, and then, wow, it just sorted our advertising numbers for us. So, right, whoever spent the most had more, right? They automatically won. So that's a very quick overview of some of the things you would do to arrays. There's a lot more that you can do. But we don't have time in a session like this to talk about everything you can do. I could spend 3 hours just on this. Yes?
What's a dimensionless multiplier? Is it to do with connecting modules?
I'm gonna show you something new.
So a dimensionless multiplier, where did you see that?
I've just come across it in literature, I was trying to find it in Diana Fisher was talking about today.
Oh, what is she doing that for? So dimensionless multiplier is just a value that we use. It doesn't have, like, were you here in the earlier session?
Sorry?
Were you here in the earlier session today? Okay, so our adoption fraction is actually a dimensionless multiplier. It's telling us what fraction of people are going to be adopted. So it's basically, it's usually a percentage fraction, right? This number or contact rate is effectively not dimensionless because it's per year, but this is dimensionless. So we're saying 1.5% who contact with the people who make contact with the doctors will adopt. It's a fancy term for a percentage or fraction of something that we don't have. Okay. Is there anything else you want to see? I could have done this with an apply to all equation, by the way. Let's just do that very quickly. If you don't understand, don't feel bad, because we only have a minute. So if I turn this back to apply to all, wow, remember. I can say, instead of 10, I can like do 10 times. Boy, where is it on here? Is it up here? 10 times, and I can type in the name of the dimension, which is company. Okay?
Will that work if your index is a label and not a number?
Yes, because underneath it's still a number. So in the equation, A is still 1, B is still 2. Yeah, good question. So underneath they all still are numbers. So I can multiply this. It means A is going to get 10, B is going to get 20, and so on, up to E, who's going to get 50. And it's a very quick way to give the benefit to E instead. And if we run this instead, we would expect, of course, E to get the most and A to get the least. Okay? So I just showed you how you can put a dimension name into an equation if you need to, which is very quick.
Do you need variables in the loop, in the arrays?
No. Wait, can you what?
You need all the variables in a loop to be arrays?
Typically, all the variables in a loop will be an array, but
Yes.
it's not a requirement.
Yeah, because here I have a loop here, and everything is not an array in that loop, and I have a loop here, everything there is not an array either. So you really need to think about what needs to be an array and what doesn't need to be an array. You can't just say, oh, it's in a loop, like you could make an array. That would be easy. That would be great if you could do that. You have to think about it a little. Are there other questions? We have no seconds left by my watch. 1 minute by that clock.
Can you array more than one variable at the same time by selecting more variables and put that at the same time?
No, you can't, unfortunately. Not at this time. But it's very fast, so typically I do it as I build it anyway. I rarely, if I have a piece of structure, I'll do this, but That doesn't come very often, except for something like this.
In the top of the array panel is a listing of all of the sets of dimensions that you've used. That way, it's very easy, if you have a model where you're using 2 or 3 or 4 different dimensions, to apply a group of them in one shot.
Yeah, exactly. So if you've used like 3-dimensional arrays or something, it'll show you what the dimensions are, and you can just select that and it puts it in there quickly for you. Other questions? Okay. Oh, yes.
What is the difference now between the
I think it's
arrays?
Stella.
No, the arrays and the sensitivity analysis. We done the sensitivity analysis before.
Okay, so sensitivity analysis is running a bunch of different parameter values on the same thing. I have 5 different things now instead of 1 thing. I can run sensitivity on these 5, right? And see how the budget might affect those 5 differently. Although in this case, it's the same model, so we run those. But yeah, so sensitivity is examining the behavior. In the example we did, we were looking at one company and the sensitivity of the model, right, for the parameters for that one company. But now we have 5 different ones, so we can run sensitivity on those 5. Although again, the behavior is going to be similar for all 5. Other questions? Great, thank you very much.